The Lexicographic sort engine is a standardized sorting subsystem designed for ordered data retrieval in relational contexts. This document provides complete technical specifications for implementation, configuration, and maintenance. The system operates on comparable element types using predefined collation sequences. All operations are deterministic and produce consistent results across multiple invocations with identical input parameters. Core sorting operations utilize comparison-based algorithms with configurable pivot selection strategies. The engine maintains internal state during sort execution through a series of transformation phases. Each phase modifies the ordering of elements according to the active collation scheme. The system supports both ascending and descending sort directions through parameter configuration without requiring algorithm substitution. Collation sequences define the ordering relationship between comparable elements. The default collation follows standard lexicographic ordering based on character code point values. Custom collation sequences may be registered through the collation registry interface prior to sort operation initialization. Once a collation is selected, it remains active for the duration of the sort operation and cannot be modified mid-execution. The partition mechanism divides input sequences into segments based on pivot element selection. Pivot selection strategies include first element selection, median of 3 computation, and random selection. First element selection provides constant overhead, but exhibits poor performance on presorted sequences. Median of 3 selection reduces probability of worst-case behavior at the expense of increased comparison operations during pivot identification. Recursion depth is bounded through implementation of tail recursion optimization on the larger partition. This approach ensures maximum recursion depth remains logarithmic with respect to input size. Stack allocation is minimized by processing the smaller partition first and iterating on the larger partition. Recursion terminates when partition size reaches the insertion sort threshold, typically set to 16 elements. Insertion sort processes small partitions of 16 elements or fewer through successive element placement. Each element is compared against preceding sorted elements and shifted into correct position. Insertion sort exhibits linear time complexity on nearly sorted data, making it efficient for small segments produced by partitioning. Context switching between sort algorithms occurs transparently without user observation or configuration. Stable sorting preservation is maintained through careful element comparison and swap protocol implementation. When elements compare as equal under the active collation, the relative order from input remains unchanged in output. Stability is preserved across all algorithm phases including partition operations and insertion sort execution. This property is guaranteed without additional data structure overhead or memory allocation. Comparison function implementation defines the ordering relationship between 2 elements. The function returns assigned integer. Negative indicates first element precedes second, 0 indicates equality, positive indicates second element precedes first. Comparison functions must be deterministic and transitive to ensure correctness. Custom comparison functions are registered through the sort configuration object prior to operation initiation. Memory utilization during sort execution depends on algorithm selection and recursion depth. In-place sorting minimizes heap allocation by performing element rearrangement without creating copies. Worst-case space complexity remains logarithmic due to recursion stack allocation. For sequences exceeding 1 million elements, empirical testing confirms heap fragmentation remains below 2% throughout execution. Performance characteristics are measured through comparison count and exchange count metrics. Average case time complexity approximates O of n log n comparisons. Best case scenarios occur on already sorted sequences processed with insertion sort, achieving linear time. Worst case complexity bounds at O of n squared for anti-sorted sequences, with poor pivot selection. Real-world performance typically aligns with average case expectations. Numeric collation extends standard lexicographic ordering to handle embedded numeric sequences. Numeric substrings are extracted and compared numerically rather than lexicographically. This prevents alphabetic sorting of numbers, ensuring item 10 precedes item 20. Numeric collation is registered through the numeric collation provider and selected via configuration parameter during engine initialization. Case-insensitive collation performs character comparison after normalization to uniform case representation. Unicode normalization is applied to handle combining characters and diacritics consistently. The engine stores original character data without modification, producing sorted output preserving input case. Case-insensitive collation incurs minimal overhead through lazy normalization during comparison operations only. Parallel sort implementation distributes partitions across multiple processor cores through work-stealing scheduler integration. Partition sizes below 100,000 elements are processed serially to avoid scheduler overhead. Larger partitions spawn child tasks assigned to available worker threads. The engine maintains sort stability across parallel execution through partition local ordering preservation. Error handling in sort operations is minimal due to deterministic algorithm structure. Division by zero cannot occur as pivot selection operates on element count. Comparison function exceptions are propagated immediately, terminating sort execution and returning partial results. Out-of-memory conditions trigger graceful fallback to single-threaded execution with reduced recursion depth. Configuration parameters are specified through sort configuration object construction. Parameters include collation selection, comparison function reference, pivot strategy selection, and parallel execution enablement. Default configuration uses lexicographic collation, with median of 3 pivot selection and parallel processing enabled. Configuration objects are immutable after construction and share safely across multiple sort invocations. Invocation of the sort operation occurs through the sort engine.execute method, accepting input sequence and configuration parameters. The method returns ordered sequence maintaining input element identity. Execution is deterministic given identical input and configuration. Empty sequences and single element sequences return immediately without modification, requiring no comparison operations or recursion.